Quadratic Functions Study Guide for the test. In number 1, the transformation from f of x, which is the parent function, to g of x has two things that are happening. The graph has been moved down 2, and then notice that the graph of the g of x function is wider, so it is a compress. On number 2, I've underlined all of the transformations that you need to include in the equation. So a vertical stretch by a factor of 4, so you're going to multiply 4 out front, a reflection over the x-axis, so then the negative is multiplied, and then lastly a translation 2 units up, so you'll add 2 at the end. So g of x equals negative 4x squared plus 2. Number 3, you can see what I've underlined, a vertical shrink or compress by a factor of a third, a translation 2 units up and 4 units left of the graph f of x equals x squared. So g of x you would want to multiply by a third, and then in the parentheses by x you're going to add 4 to shift it left, and then add 2 to shift it up 2. Numbers 4 and 5, you want to describe the transformation. So I've underlined in red what has been added to the equation. Notice in 4 you have a negative out front, which will create an x-axis reflection, and when you add 2 to the input, you shift the graph to the left. On number 5, you have a 5 multiplying out front, which is a stretch by 5, and then the 3 being subtracted at the end will shift the graph down 3. On number 6, you want to graph the function. So first recognize the form that it's in, which is vertex form. Pick out your h and k values, and that's your vertex. Remember, the axis of symmetry is the x value of the vertex in the equation form x equals 4. Your domain will be all real numbers, and then the range will be y is greater than or equal to 2, which is the y value of the vertex. And we know it'll be greater than because we can tell that the graph will open up. Now if you look at the table, I've placed the vertex and then x values in the negative and the positive direction. Pause the video, plug those numbers in, find your y values and graph it, and then come back and check your work. Your values and your graph should look like the ones that you see in the video. Make sure that you sketch in the axis of symmetry. You'll see that the graph fits the equation and that it's a stretch. It's narrower than the parent. It is shifted 4 to the right and 2 up. Also, because the parabola is opening upward, that means its vertex is a minimum. It is the lowest point. In number 7, notice that this graph is in intercept form. So the first thing you want to do is to pick out the x-intercepts, the p and the q values. So p is 4 and q is negative 2. Then we want to find the vertex. So you're going to find the middle of p and q to find the x value, which is 1, and then you'll plug in 1 to find the y value, which is 3. So you have your vertex, which is 1, 3. Your axis of symmetry is the x value of the vertex. In equation form, it's x equals 1. Your domain will always be all real numbers. And since this graph opens down because of the negative out front, your range is y is less than or equal to 3. So now we can place in our table actually our x-intercepts and our vertex, and we can use those 3 points to graph. So we have negative 2, 0, 1, 3, and 4, 0. So pause the video, draw your xy axis and plot your points, and then come back and check your graph. So the graph will open down. Make sure you dash in the axis of symmetry, which is right where x equals 1. And notice that it is a little wider than the parent function because of the 1/3. Since the graph opens down, that means the vertex is the highest point, so this graph has a maxima. Number 8 is in standard form. So even though you don't see a c value, it is 0. So start by picking out your a, b, and c values. And then find the vertex by taking the opposite of b, dividing it by 2 times a, which will give you positive 1, and then plug that in, which will equal 2. So your vertex is the point 1, 2. The axis of symmetry is x equals 1. The domain is all real numbers. And since this graph opens down, then the range will be less than or equal to 2, which is the y value of the vertex. Now over at the graph, place your vertex, point 1, 2 in the middle, and then go in the negative and the positive direction. Pause the video, plug in those values, graph them, and then come back and check your graph and your points. So your graph should open down and be a little narrower than the parent function. Since it does open down, the vertex is the highest point, so this graph has a maximum. So in number 9, a passenger on a lifeboat shoots a distress flare in the air. The height in feet of the flare above the water is given by that equation, where t is the time in seconds since the flare was shot. So look down below where I have written first and then the equation. Notice next to the first t, I went ahead and inserted a parentheses and put a -0. Now you can see that this is an intercept form. So sometimes you'll have equations that are in a certain form, but they don't look like it at first. There's one like this on your test. So notice that if you put in a parentheses and a -0, now you can see those two values. The passenger then shoots a second flare whose path is modeled in the graph, which I've marked. So the two questions we need to answer are which flare travels higher and which remains in the air longer. Well, let's look at the path of the second flare. So we can see that its vertex, its highest point is 3.5 feet out, in 3.5 seconds, then it is 196 feet in the air. That is its maximum, its highest point. So we know that the height of the second flare is 196 feet, just by looking at the graph. We can also tell how long the flare was in the air just by looking at the intercepts. Because if you see it's shot at 0, 0, and then lands after 7 seconds. Now the first flare we're going to have to do a little bit of work, but we'll just need to find the vertex. So we're going to pick out P and Q. P is 0, Q is 8, and then we'll find the X value of the vertex in order to get to the Y value. So we're going to add those values, divide by 2. So that flare halfway through its path is 4 seconds in the air. So now if we plug in 4 seconds, we'll be able to tell how high that flare went. Alright, so when you multiply those two together, three numbers together, it's -16 times 4 times -4 gives you positive 256. So it goes 256 feet in the air. So the first flare was higher. And then, which one was in the air longer? So we know that the second flare was in the air 7 seconds. The first flare, we know that halfway through its path, it was in the air 4 seconds. So that means if we add another 4 seconds, it was in the air 8 seconds. So the first flare was also not only higher, but also in the air longer. Look at numbers 10 and 11. You want to write the equation of the parabola. So if we read these problems, it will tell us how to work them. Number 10 says that the parabola passes through the point 112 and has a vertex of 10, -4. So that means you're going to use vertex form of a quadratic equation to write it. Number 11 says that the parabola passes through points 4, 3 and has x-intercepts of -1 and 5. So that means you're going to use the intercept form of the equation of a quadratic. So these formulas will be given to you on your test, but you'll need to be able to know them and to be able to use them. So my first suggestion, let's go back to number 10, is when it gives you a point, you want to label that X and Y. And when it says vertex, label it H and K. And then you don't have to think when you plug it in. You just plug in those numbers. So I want you to pause the video, plug in the values and solve for A, and then come back and check your work. So on number 10, you should have got 16/81st, and you'll want to leave it in fraction form rather than rounding a decimal. So that your equation, once you plug that in, will be y equals 16/81 times x minus 10 quantity squared minus 4. Now work number 11, so plug in 4 and 3 for x and y, and then -1 and 5 for p and q. Solve for A, and then write the equation. But pause the video and do that, and then come back and check your work. Alright, so on number 11, you should have got 3/5 for A, and then plugging it into the intercept form of a quadratic equation, you'll get y equals -3/5 times x plus 1 times x minus 5. Now look at number 13. So the problem says that this parabola passes through, let's go back. So 12 says passes through the point 0, -18 and has x-intercepts of 9 and 1. So that means you'll use the intercept form of the quadratic equation. So then plug in x and y and p and q and solve for A. So you should get -2. And then when you plug it in, you'll say y equals -2 times x minus your p-value, x minus your q. And then finally on number 13, look at the graph and you'll see what you've got. You've got two x-intercepts. They're right on the x-axis at -2, 0, and 6, 0. And then you have the point 0, 3. So again, you can use the intercept form to write this equation. So you're going to go through the process again of plugging in the x and y. So that's the point 0, 3. So 3 goes in for y, and then 0 will go in for x. And then we'll have our first x-intercept at -2, so we need to add 2, and then 0 minus 6. So when we simplify that, we'll have 2 times -6, which is -12, and then 3 divided by -12 will leave us with -1/4. So now we'll put it together, so we'll say y equals -1/4, that's our A value, open a parentheses, x, and then subtracting a -2 is like adding 2, times x minus 6. So for each of these where you're writing an equation of a quadratic, you just look at what you're given, either the x-intercepts and a point or the vertex and a point. Use that form, which will be provided on your test. Find the A value and then plug that A value into the equation.